We have Daniel Cohen with us. He has been a robotics engineer throughout his career, and currently he serves as a software control systems engineer at Brembo. Let's try to extract most out of his experience throughout his journey of robotics engineer. So, Daniel, how are you?
Pretty good. It's good morning here in Silicon Valley. It's at 8 a.m. on a wonderful Friday.
And it's a wonderful Friday, 8 p.m. in Pakistan. And I'm really happy to have you on my first podcast. And the focus of this podcast is going to be about benefiting from your experiences, from your knowledge about control space systems specifically for robotics. And that's quite interesting topic because of the reason that a lot of my students, a lot of my friends and colleagues miss the point of control systems in robotics. So would you like to start with some light on control systems in robotics?
Sure. So I would say, from a control system standpoint for robotics, if you're looking at a mobile like a manipulator, it's super critical for each one of those components to move properly. So if you put a command out there for a robot to move to a location, that has to be processed from a control standpoint. So kinematics turns into dynamics, but at the end of the day, there has to be a controls request to move the robot somewhere as well.
Okay, a general overview of control. We'll also go into deep dive of some algorithms and some tools that help you build this control system side of software. Let's start with the interesting part, which most of the people would be interested in, is career side of robotics, because as we talk about robotics, it is multidisciplinary and there is a lot of fields connecting to it, specifically vision side of things are getting connected to it. Now, as I have a goal to be good at robotics, a good career in robotics, what are the available fields that we have in robotics software side specifically? Let's leave the hardware side. Let's just discuss software side. What are the roles that most of the companies, specifically in Silicon Valley, they have different types of role titles?
Yeah, I think that's a great question. I think you're going to find a lot of the traditional engineering roles, but more focused with robotics. There's a much wider band out there for people. So if you have an expertise in mechanical engineering, let's say, you could do mechanical engineering, but focused in that. You can do electrical engineering for designing PCBs. There's vision, of course, which is incredibly popular nowadays. I would also go along the lines of AI and machine learning for robotics. Of course, I have more of a controls background, so try to work on and solving specific controls issues. So I think that those are some of the bigger areas. Path planning, simultaneous localization, and mapping is very popular. I think there's an entire group of people who focus solely on ROS, and I would say that there's just sub disciplines. So if you're a ROS C++ person and that's what you're passionate about, that is a perfectly reasonable thing in Silicon Valley, and that will get you a whole career. So for me, I try to go closer to Python most days. So that's usually where I do best. I can do some C++, but surprisingly, I've gotten quite far for using Python and MATLAB and Simulink and Stateflow now. So
Interesting. The last software did you named Stateflow?
yeah, Stateflow. Yeah, so it's a MathWorks product. It was relatively new. It's within the last, I would say, 5 years or so. I think it was like 2018 and 2019. They put it out. MathWorks put it out. So if you're using Simulink, you can also use Stateflow, and Stateflow is a diagram-based language from MathWorks that helps you kind of understand the states of the problem. So if you're building like a large project and your robot needs to go through multiple phases of a system, Stateflow could be a good option. To me, it was new to me as well in the last couple of years. So I've been learning it.
Interesting. So the general flow of students is starting C++ in their bachelor's degree, then learning about Arduino, creating a line following robot. At that point, they get introduced to proportional controller for controlling the line following robot. Now, at this point, they think that we now know a lot of robotics and we should pursue robotics. So, what should be the next steps regarding specifically the title that is robotics software engineering? So, how they
Yes.
should move towards that?
Yeah, so I think the first couple steps are putting together I would say, a website or resume that is easily distributed. So filling out LinkedIn profiles, being able to put together your own website, that's kind of marketing yourself.
Okay.
And then you kind of need to find out really passionate and good at from a software standpoint. So maybe it is vision, maybe it is with C language or C++, and you feel like you can interview well with those languages. I think it's popular for people to talk about doing leak code or some sort of online interview system. So you might want to practice a few problems just to prepare for exams that could happen. But I think having a good resume and being able to showcase your work with GitHub and show that you're passionate about the projects you're working on is a big start.
Interesting. So, marketing yourself,
Yes.
specifically website, social platforms, showing your work, your interests about robotics, and GitHub, obviously, software development, GitHub. Let's get back to control systems.
Sure. Sure.
The thing that interests me a lot, there are complex things about control, fuzzy control, optimal control, and a lot of subtypes in control system. The problem that I see, most of the people are interested in control system, they implement PID control, and the next steps, for example, LQR control, the MPC control, these are quite complex. As a robotic software developer, should they be writing from scratch or using certain library? They are currently learning phase. They are not at a job.
Yeah, I think that the answer to that question is, I think, very ubiquitous across like all industries. So if you pick it up and you're a savant, let's say, and you can do that without base libraries, of course, people should try. But in all cases, everyone should try to do it without. There are so many good libraries that can help you with optimal control problems that it would be almost impossible to do it without it. And the same thing, your employer or whoever you work with, they're not as concerned with what library you're pulling in. It's more of a question, are you doing it the correct way? Is it going to work properly? Is this a good technique? And if you can answer those questions, then the library becomes kind of a secondary point. If you can pick between LQR and MPC, and you know the differences, and you know how to apply things properly, and you know the sensitivities of your problem, that's more important, in my opinion, than I'm not an expert in the low level library. I can't write this from scratch, which is what usually people think, and I would say that it's more important to understand the higher level problem.
Okay. Just
Sure.
the experience that I did with LQR, I thought that it's a simplest algorithm. Let's try to implement it with a basic mobile robot. And
Yeah.
interestingly, when I started the implementation and specifically on its optimization part, I learned a lot of things from it. I first of all experienced the amazing power of mathematics, how it can solve numerically things. But it is a good experience. Obviously, as I teach, I have to go through certain algorithms, and it as at a learning stage, this was a great experience, specifically opening more doors and more interest into control systems. How powerful this field is.
I totally agree. I understand what you're saying, and I think that that's the correct approach. LQR, I think, is more tractable, and you can do it. And if you can understand the low level linear algebra that's necessary from an education standpoint, it's absolutely critical. Like you said, it's 100% critical, and that's what gives you the confidence to move forward and solve other problems. So I totally understand. I totally agree, and I don't disagree with what you're saying at all.
Sure, sure. Now, the opportunities for robotics developers. As you are in Silicon Valley, you have a lot of opportunities. There are a lot of people around the world. They don't have much robotics companies in their country, specifically in third world countries. Now, the problem they face is no opportunities, some freelancing work, but that is not sufficient. What should be their steps to should they be moving abroad and applying to the companies, or they should get the job and then move? What should be a preferable choice for the employer specifically?
Yeah, I think that that's a really difficult situation, and I understand it to some degree because I had to leave my hometown of Arizona and I had to move to California because there isn't any real robotics jobs there either. So I can empathize. I would say start freelancing. That's a good option. I think if you have a solid resume and you have something that's attractable like ROS and C++ and Python, and it's clear that you're going to help an organization, I think that they probably would move you from your home country. But in many cases, they do let you work remotely. I know that for a fact with Google. There's Google robotics engineers who did have visas and then they eventually moved back to their home countries. So I think it is quite possible in both cases. But yeah, chicken and the egg, right? So do I get the job and then move, or can I take a job here and then move? And I would say the right answer is you just got to start. So if that's what you're comfortable with and you want to stay in your home country and try to do some freelancing and add to your resume, I think that's a great location. If you really want to try to start with just moving, then you might have to take a different job potentially to start with. It may not be as focused as you exactly want.
Okay, very well structured. I think you have prepared this question. Okay. We are looking at AI boom, chat GPT everywhere, software developing AI coming up. So, what is for robotics in this, specifically software side?
Yeah, I would say that there's a big power still with machine learning. AI, generally speaking, I think can go well with reinforcement learning with robotics. Most of my in graduate school was focused around actually UAVs and controls, and specifically looking at how to use reinforcement learning to tune PID controllers. And that was because I felt like there was a correct balance there between using AI, but also to tune something that could be done numerically, but generally speaking, is just generally difficult. So that's you have to find a problem that still is actually going to be around for the long haul, and utilize artificial intelligence to solve that. I use it at work, not that system. I use general other systems for work. So I think that it's very, very powerful. I would recommend people to do some research in the area, understand the differences between reinforcement learning, machine learning. What does AI actually mean to them? And then kind of like how to deploy it. At least do one deployment throughout your your school work.
Can you explain more upon
Sure.
deployment, because deployment comes on the app side as well?
Yes. Yeah. So I would recommend, even if it's a super simple problem, or even if it's a base example from MathWorks or MATLAB, take one problem and try to see it from the beginning to the end, because it's easy to, I would say it's easier to train the algorithm and get the accomplishment off of that. But at the end of the day, you will have to take that software and actually put it into something that's going to run that algorithm. And nowadays, that's actually a lot of where the work is happening, is trying to turn um, machine learning and artificial intelligence systems into something that can run quickly. And that's, if you have an Arduino, that would be exactly what I would try to do, is try to put some artificial intelligence program onto their Arduino. And even if it doesn't go as well as you'd like, you at least learn the fact that, like, generally speaking, it's very hard. So that's that, and I work in that environment because I work in a C based environment most days, and we have those exact same questions. How do we translate machine learning to something that can use something with C? Um, and that goes from like artificial intelligence to like if statements to like lookup tables, and like that's kind of
Registers.
that's the questions that we ask nowadays, is like, could we move this into a lookup table? Because if we can do that, then
Oh,
it's going to run really quickly and it's going to have all the information that we need.
wow. Wow, hard things. Coming back to registers, you mean?
Yeah, exactly.
So
Exactly.
that's an important thing, because when we start AI, we are only looking at Python, and when it comes to hardware, some small hardware, we definitely go with C++. So for a robotics person, what should be the primary choice of language to be very good at it?
Oh, well, I definitely think that Python is the new aged answer. I think MathWorks is a wonderful resource. I think MATLAB is great. Simulink is wonderful as well. But having Python in your toolbox is incredibly important, especially because it's free. And it's expensive to buy MATLAB yourself. It's expensive for companies to run it as well. So being good at Python gives you flexibility. It makes you more attractive as a student who's going into their first career. It gives you flexibility. So I think that also being able to write libraries for Python is really powerful, more powerful in my opinion than being able to write something for MATLAB. But I have some bias there because my last main project for the last 3 years was like 100% written in Python, and
Okay.
it started in C++, like you said, and it moved to Python. So I have like it's quite an issue, like you said. Like it's a mental thing where you think like, well, we should move from Python to MATLAB, or we should from Python to C++. And I think that those are still very popular depending on what you need. But understanding the timing constraints of your problem kind of tell you what you really need to do. And I think Python is very popular. Zig is new. I'm hoping Zig is a popular language that comes around soon.
Interesting. You bring up MATLAB a lot. Let's understand
Sure.
MATLAB in detail, because whenever you talk about any researcher, electrical engineering side, mechatronics side, he brings up MATLAB, and so every control system person brings up MATLAB. Why is that? What is MATLAB?
Sure. MATLAB is a matrix laboratory. It was developed by MathWorks in the 90s, I believe, from MIT, and it's natively works quite well actually with GPUs and your CPU that's on your computer, and computationally allows you to work with matrices and vectors in a more native way. And that's really why I believe it's super powerful. Is a lot of the work that you do in an undergrad standpoint is going to look like calculus and differential equations, but the further you go on in your career, graduate school, things of that nature, the questions are going to be more of like linear algebra based. But now they're going to look like also different. They're also going to look like linear algebra problems, and that makes it very suitable for MATLAB. I think that's why Python is just right next to it. If it could do it just a little bit easier, like NumPy arrays are not just as suited as well as a matrix in MATLAB. But computationally, it actually does very well because it's C based underneath the hood in Java.
So, can you bring the code from MATLAB to hardware directly?
Yeah, so nowadays there are options to do that. That's something that we do. I have a MATLAB C based build tool that actually can compile and build C libraries by itself. That's been done in the aerospace industry as well for quite a number of years. The F-35 from Lockheed Martin actually worked that way with MATLAB. I didn't know that either. I was very surprised, but they apparently do some like automatic generation of their code through MATLAB. And so, yes, you can do that. You can also do it from hand. I think if you're building like a safety related project, you probably are not going to do it that way. You probably will write it from scratch.
Definitely. Writing from scratch the C conversion or the code?
Just the code itself.
Interesting. MATLAB, number one tool. Then the second one.
Python. That kind of flips. I would probably go 1-2-1-2. But for me nowadays, I would say my number one tool is MATLAB. Number two is Python.
And what specifically you do, if you can?
So I lead the controls efforts for Brembo. It's an automotive brake manufacturer for a new project that they're building, an electromechanical brake caliper that's going to be hitting the market in the next couple of years. With the advent of self-driving cars and newer technologies for automotive systems, people are trying to move away from hydraulically actuated brakes, and they're trying to do it with electrical systems. So I'm utilizing a lot of my experiences with robotics in general to help build an electromechanical brake caliper, which is really quite a pure mechatronics project. So rather than having one robot with 4 articulated joints, now all the joints have been spread out and we got each one on each corner.
Okay, interesting. Coming to the other tools that you mentioned, ROS specifically, it's very popular. But in my perspective, ROS is again just a tool. It limits you to certain capabilities that you have to develop, like certain algorithms are not there. But still, as you are in Silicon Valley and you have experience in robotics, ROS is going to make people stand out or not?
Yes, I think so. At least in my opinion, it's a signal for most standpoints of like this is someone who's incredibly brilliant and can pick something up that's usually considered to be fairly difficult. It's a question that comes up every single place I've ever worked is this a project that we should do in ROS? And if you have experience in ROS and you're an expert, you might be able to sway that conversation towards your skill sets, and that gives you the chance to be a leader for a company. And that I think is a very positive thing. So having some experience in ROS for sure is a positive, and if you're able to do it quite well, I would say it's a huge accomplishment. We have projects as well that like exactly like it's automotive, so people think like, well, how does ROS and automotive work together? And it's like, well, there are projects that we talk about that potentially could be, in that area. And I think that that's very hot. That's a very popular subject is how do you put ROS on a car?
Obviously, because its communication system is easier as compared to you if you build from scratch or use MQTT. There are a lot of debates on the real-time efficiency of it, but still, if you want to directly build something, sensor data processing, if someone is good at it, they can directly bring a lot of data processed over the network and things. Coming to very interesting thing, that is, let's say you want to hire 10 people with your experience. One is a junior, one is a mid-level, and one is a senior. So how can you define a robotics person that would be ideal for you for each level? If you want to start from senior, I think it would be better.
Sure. For a senior level person, I think that they need to have a very good handle on the tools that they're using and their own expertise. So let's say they're maybe a computer vision expert. You'd like to see that they have solved a project, maybe not entirely by themselves, but they've at least taken a lead role and they've been able to mentor other people or solve a problem to a very high degree, I would say. And then it kind of works down from there. I think it's more difficult to find junior level people are very difficult to find because by the time that you've kind of gone from not experience to experience, it's a gray area. So that's probably someone, in my opinion, who has maybe not led projects as much, but has taken a large role on those projects and has done quite well on those projects. They're in that range. They're going to be moved up. The lower you go into a more junior role and to someone who hasn't really worked as much, you would want more enthusiasm and more kind of raw talent, and less of a question of utilization of that talent, just an evaluation of what their capabilities are. So that's usually what people are looking for, is someone who's highly capable, and then they put them on a problem and then they can solve that problem. And the more senior that person is, it should be more evident that they've solved those problems. But the younger they are, it's more evident that they just have general capability and that they would be a good teammate and someone to work with.
Interesting, very well rounded. I think you have been practicing these things.
I've been living them, so I get to make some of those decisions. I've made them before at companies, and it's just something that comes up is who do we bring on board? Why do we want them? Should we take this person or this person? And yeah, just kind of that's what it is. We want the best person we can find. We want them to work well on the team. We want them to have an enjoyable experience as well. So it's a life. So if you leave academics and you kind of come into a normal engineering job, then it's going to be a readjustment period, and then it's just kind of a question of like, are we an organization that are going to be able to help them the same way that they're going to help us?
Yes, thinking for the company is also a task for the person who is joining, that I have to work for this company, not just to have a salary and that view, but also they are providing me an opportunity. They are taking a risk sort of with the money and their time. I want to push on this a little bit more. I will be giving you a sort of a background. Then you have to categorize what is this level. Okay, are you ready?
Sure. Yeah, I'm ready.
Okay, I have been working on a drone with, and I want to integrate a vision system on it for surveillance purposes. That if I give a picture, so on a mobile app, and the drone starts to find that person. Once it finds it, then it is going to keep following it. It's a tele drone, very easy drone, simple monocular camera, and I have version control of my code onto GitHub, and it took me 7 months to build this. I was working alone, and I introduced ROS with it. Every sensor processing, all of the things were on ROS, and we were using C++. For the vision side, I was using some computer vision libraries. And I have been working with other robots, but I have not worked in the company specifically. So what do you think this person fits where?
Yeah, I think we'll start with just like kind of what I would say like ranking. I would say they're probably more senior to be honest, because they don't have the same, excluding where they're from, but generally speaking, that is quite important in my opinion. If it was from a U.S. university and it was just a class project, it would mean something differently than if someone did those independently. They did that from a different university, so that is quite a difficult task. That if all the code is there, it's in the GitHub, there's a video, everything's well documented, this person's writing very clear C++, very clear Python, then in my opinion, you're pushing towards junior to senior and senior potentially. That's the question is if you give someone a senior role, they're going to have to lead projects. And that's really what you're making that evaluation on. So probably not you. Yeah, I would say something junior, senior. It's very difficult though to be hired immediately in a senior role, so that's kind of you might have the capabilities to do that, but they might have to bring you in at a lesser title than what you would want, and then prove yourself in a year, and then kind of go from there.
Definitely, obviously, there are a lot of other things that are involved. Just from skill perspective, hard skills. I'm just trying to get your expression, your from your experiences, your ideas. Just one more.
Yeah, of course.
I made a F1/10th racing car. It's totally autonomous. F1/10th is the one that is 10th of the size of an F1 car, and it has a LiDAR upon it. We are not using AI. We are using model predictive control for its 2D LiDAR to be processed and detecting its path in the racetrack. Although it is totally indoor, and we have developed the code with the team, I was leading it, and I was developing the MPC algorithm from scratch. I wrote it from scratch, understood the dynamics, implemented all the parameters, and fine tuned it. I was using only C++ and not MATLAB, Python for visualizations. And it was a quite long journey, although we lost the tournament, but still, it was quite a long journey for learning. So, what do you think about this person?
I would say it's very impressive. I would say anything that is competitive based tells me something completely different than if someone is doing something that sounds less academic potentially, but more competitive. That's very positive. I would say that they're a very capable person. They understand kind of a cost benefit analysis of what algorithm to use. They're not using AI just to use AI. They're using something that they feel would be confidently put onto a field to solve a problem. So I would say that they have quite a good bearing on how to pick algorithms. And yeah, I would say that's quite a great project, honestly. I'm a competitive, so I always have an affinity towards things of that nature. I work in automotive, so it would, to me, that's would be something that would be a good fit. It's like, oh, you already have a passion for, this area. Clearly that makes sense. Clearly you can pick algorithms, and you have the technical capability to actually utilize them. And I think that those are very good.
Interesting. It's been 40 minutes, and thank you for your time. Just going to the last phase. Are you enjoying, or are these all just questions
Yeah,
being?
I'm having a great time. I'm happy to be here. I'm always excited to talk about robotics and passionate on the subject. And I really honestly hope that there's smarter robotics engineers than me in this world who are in the future and are in a class somewhere and are ready to come out and solve new problems. That's always what I'm looking for is the next great people who are going to fill in roles.
Interesting direction and noble direction as well. In my opinion, as a solution, what I came up after working with certain companies, I just worked with certain companies that are not in my country, remote work, and then I left software development side. We spent a lot of time in a career. For example, it took number of years on your experience, number of years on my. What we as a human being have to do is to provides the same level of knowledge to the coming people but compress the number of years so they can save time, but they get to that certain level of skills. Obviously experience cannot be replaced, but their time can be saved. That's what I think is the job of a person.
Yes, I totally understand and totally agree. If I knew what I knew now, I could compress it like you said, and I could distill it, and and I could give it to someone in a much more refined manner. And I think that that's very noble as well, and something I appreciate.
Thank you. Coming to the part of future. So, from control system, what we see as a future for robotics. I have given the thing that currently no commercial thing is using reinforcement learning. Is that the case?
Yeah, I mean, I would say that there's probably a few companies out there that are pushing those bounds. I think that if I had to pick one, it would probably be Dynamics, along with their big dog. I think that they've used reinforcement learning to train their control system. I think that's possible. Yeah, but beyond that, I think it's very difficult. I think mostly it's academic.
I recently came around a Boston Dynamics there, the Atlas One they have, and
Okay.
they started to the same way that you are telling that they are using reinforcement learning for just fine tuning the control system algorithms. That's
Okay.
that's the current case they are dealing with. So why is this so hard? Can you explain a little bit that when we talk about just fine tuning MPC, let's say, so I know MPC is a big thing, but fine tuning MPC is going to require reinforcement learning. What is this knowledge that I'm skipping here?
Sure. I think the only thing that would be skipped is the fact that you have basically a search algorithm that has to get done in a different space. So rather than searching the floor for something, we're searching for new numbers that help us solve a problem. And a great example, a non machine learning version, is for ASML, who makes lithography equipment. And what they used to do, and from what I've heard, they still do to some degree, is they basically outline all the numbers they possibly can, and they try as many possible combinations until they feel like they have a best fit solution. I think that that's very time consuming, and I think that reinforcement learning, if you can do it in a simulation, gives you an opportunity to do it much quicker. Generally speaking, you're still searching for numbers to solve those problems. Do you want to provide more control authority, less control authority? How far into the future can we look? Computationally, that's a question that comes up. Those are tunable parameters that have to be searched upon. And reinforcement learning gives you an opportunity to change those parameters while just something on the computer, you type it, it provides a constant working solution, and you can do something else. I think the good example as well is with reinforcement learning examples with PID have been kind of ebbs and flows in popularity, but still is quite an important thing, especially the D piece. People can tune the P and the I actually quite well by human beings, and there are decent algorithms, but the D is so difficult to get right that would benefit quite greatly. I think that's a more direct example. But for MPC, I can at least recall like control authority and time for search.
Interesting. Hopefully, people can understand this discussion because none of the people I have ever met understood MPC. But let's say, interestingly, there were some master students who never heard about LQR as well. I was like, what are you doing as a researcher?
Yeah, I think the subjects are kind of robotics and controls is a little older, I would say, in some ways, and it hasn't necessarily trickled into robotics from that standpoint. I think I have an interesting background because I mostly actually came from a mechanical side of things, but my first role I ever took was actually at Microchip Technologies in electricals, like electrical systems, and then I did aerospace, and then I moved to industrial robotics, and then I did like laser manufacturing before I did automotive. So I think for me, I've had like variety of experience, so I think that I can kind of draw on it. But if you're in school and you take that one controls class, you're only getting an older version of controls in many cases, and it's still an important version, still what we rely upon, but there's so many new algorithms out there that it could become overwhelming. And I think that especially in ROS, they don't really cover that necessarily. It's just an assumption many times where we'll just use torque control or we'll use position control, and the robot will go wherever we tell it to go, which is sometimes the case and sometimes it's not the case. But
Definitely. Yeah, that is why I always mentioned ROS is a tool and it is limited. Don't rely a lot of it on it. specifically how to currently get into robotics. It's not just about getting into AI, implementing all algorithms of AI, not implementing, it's like running models, people, what they are doing, but leaving the main aspects of it, solving the problem, improving on the problem, and working in a team and looking into algorithms in deeper sense. That is what is required in the industry. And that's what I have concluded from your discussion. And do you want to give a message first to the students that are looking forward in robotics and control systems?
Sure, I would say definitely. I 100% agree with everything you said. And I would say that there are students in classes right now across the world who are going to do amazing things. They're in their seats right now and they have opportunities to solve new problems, to help the world in a new manner, to make the world a better place, and to help themselves, help their families, help other people's lives. And it's going to come down to a question of people who actually do exactly what you just said, which is focus on solving problems.
Okay, interesting. Thank you. Thank you, Daniel, for your time. It was a really great discussion for people who want to get into robotics as a career, and the experiences that you have shared and the way we should look at opportunities as well.